All right, guys, a couple more things I wanted to remind you all. So just a reminder that if a problem asks about the total distance that you traveled on some interval from, some time A to some other time B, that gives you, or the way you do that is you find the integral A to B of the absolute value of velocity. Now, another way that you can think about that, of course, is the integral A to B of your speed, because that's what the absolute value of velocity is. And remember, with an absolute value, you're counting the positive as the negative, all as positive. Okay, let's talk about some more types of problems. So let's suppose this example comes up. So someone says from the interval 0 to 5, so from t equals 0 to t equals 5, an object moves with velocity v of t equals 2 minus the natural log of t cubed plus 1. And then it asks you to find the time or times when the object changes direction on that interval. Okay, now let's talk about what a change in direction means. A change in direction means that you are traveling in the forward direction and then you switch to go to the positive direction. So your velocity is positive and then you have a negative velocity. Or you're going in the negative direction, meaning you have a negative velocity, and then you switch to a positive velocity. So what's happening here, if you're changing direction, your velocity is changing sign. Okay. So what that looks like on this, well, this I forgot to tell you was a calculator problem. So what you're going to do here is you're going to graph this interval v on the interval 0 to 5 and ask, where does it change sign? Where does v change sign? So where do you go from a positive to a negative value? So anyway, what you're going to do when you go ahead and do this is you'll graph this, of course, and the graph looks like this. On the interval 0 to 5, it goes up and goes something like that. So when you're above the graph, of course, that means you have a positive velocity. When you're below the graph, that means you have a negative velocity. So that moment where you have a sign change, that's where you're changing direction. So that's the point right there, and that happens at t equals 1.85557. So that's where your velocity changes sign. And not really much work to show on a problem like this on an AP test. It would just be a calculator problem. One other type of thing, you might also see a problem when it asks, when is something at rest? Well, if something is at rest, what that means it is not moving. Okay. The other type of problem that I wanted to remind you about and have a little refresher on is what happens if you have a velocity graph. So when you have a velocity graph, whether it's on your calculator or drawing, think of this as, it's like one of those problems where you have an f prime graph and you're asked about the f, where they give you a graph f prime and ask about concavity, max and mins, all that stuff. So let's say we have a graph of velocity that looks like this. So when you have something, I don't know, like that or whatever. So this is a graph of velocity with respect to time. Now, when you're above the axis, what that means is your velocity is positive. So that would mean that you're moving to the forward direction, whether that's right or up or whatever, doesn't matter. When we're below the graph, that means that your velocity would be negative, so that would mean that you're moving backwards. Okay. And of course, if the question asks you, how do you find acceleration? Well, acceleration, we know, is the derivative of velocity. So what you do there is just find the slope of v. So for example, if I ask you where is acceleration negative? Well, that would be in this region right there. So in that red region that I just drew, that red region is where acceleration is negative because that is where my slope of v is negative. This is kind of like what you should be writing up if this is a free response problem on the AP test. Okay, so that's saying your v prime is negative. Okay, and of course, if you have acceleration, if you have velocity, you need to find position. Well, then what you need to do is you need to integrate v and probably use the FTC. So just in general, when you're doing these problems, right, I don't want you to think too much. When you have these, when you have your position, that's like an F. When you have a velocity, that's like an F prime. When you have acceleration, that's like an F double prime. So if you have to go down this chain, you're just going to take a derivative to get from position to velocity or acceleration. If you're going up the chain, you just need to integrate. And a lot of times the FTC is going to come into play in those. Okay, so those are just some tips. I know a lot of this is review. Good luck on the homework. Have fun with it, and I think you'll enjoy doing the problem solving. Thanks for watching.